Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n plus 2 whole factorial equals to 60 times of n minus 1 whole factorial, and we need to solve this problem for the real values of n. So the very first thing we are going to do is, here first we use the recursive method in order to open this factorial sign. And you know about factorial, and now I can just little bit explain about the factorial. You know that if we have n factorial, we will write it as n times of n minus 1 into n minus 2 and up to so on, 3 times of 2 times of 1. Similarly, if you can open the factorial sign and you break this multiplication at any time, and you know that if I can write it as n factorial equals to n into n minus 1 into n minus 2. If I can break this product at up to n minus 2, then I can just write here the factorial sign. So now I can use this technique to open these factorials, and after that we will find the values of n. So in the next step we will move toward the question statement, and our question is n plus 2 factorial, and now we can open this n plus 2 factorial up to n minus 1. So now you will decrease 1 on each term, and you will get here n plus 2 times of n plus 1. When you can subtract 1 here, then you will get n plus 1, and when we subtract 1 here, then you will get n, and when we subtract from n, then we will get here n minus 1 factorial, n minus 1, and we here we have n minus 1 factorial, so I can just break this multiplication at n minus 1, and I can write here n minus 1 factorial, and this whole equation equals to 60 times of n minus 1 whole factorial. And now you focus on both of the sides, and you will see here we have n minus 1 factorial is cancelled out by this n minus 1, and we will get here the three factors, which is n plus 2 into n plus 1 into n, and we move this 60 in the left hand side, and it will becomes minus 60 equals to 0. And in the next step we will multiply all these factors here. So now first I can multiply on n plus 2 and n plus 1, and you will get here n squared plus n plus 2 times of n plus 2 and minus 60 equals to 0. So now here we can just add or subtract the like terms, and you know that the like terms are n squared, sorry, here we have n, it is multiplied by each factor. So now we will write it as n squared plus 2 times n plus 2 times of n will be equals to 3 times of n, and plus 2 into n minus 60 equals to 0. So now in the next step we will multiply this n on each term, and we will get here n cubed plus 3n squared plus 2 times of n minus 60 equals to 0. So in the next step you will just see here, now we can just make the factors of this equation. So in order to find the factors of this equation, here I need to take some little bit add or subtract some terms here, and now we can first modify this minus 60, and now we write it as n cubed plus 3n squared plus 2n, and now we move minus 60, so we can write this minus 60 as minus 27 minus 27. So minus 27 and minus 27 will be equals to minus 54, and we write minus 6 equals to 0. So if you can add these three terms, then you will get minus 60. So we break this minus 60 in these terms form. So in the next step we will rearrange the terms and we can just combine this n cubed with this minus 27, and you know that minus 27 will be equals to minus 3 cubed, and plus we will combine 3n square with this minus 27. This and this are combined and we get 3n squared minus 27, and after that we will get this 2n and this 6, so we can write it as plus 2n minus 6 equals to 0. So here I just make make the pairs of these terms, and in the next step we will use here the nice cubic and squared formulas. So now first I can use the cubic formula here, and you have a cubed minus b cubed, it is equals to a minus b times of a squared plus ab and plus b squared. And now here you take common 3 on these two terms and you get 3 times of n squared minus 9. So when you take common 3 you will get here 9 and we will write it as 3 squared. And similarly here we take common 2 and you will get here n minus 3 and this whole equals to 0. So now you will focus on all these terms, and here you see here we have some common terms. So you see that n minus 3, and when you can open this formula then you will get here n minus 3 times of n plus 3. So we take common n minus 3 and we get n squared plus 3 times of n plus 3 square will be equals to 9, and here you have n minus 3. You know that this factor will be equals to n minus 3 into n plus 3. So when we take common n minus 3 then you will get here n plus 3 and we multiply this 3 by n plus 3 and you will get it here plus 3 times of n plus 9, and now we take common n minus 3 and here you get only 2 and this whole equation equals to 0. So now in the next step we will just add the like terms here, and you see that the like terms are n minus 3 times of n squared, and you have 3n plus 3n which is equals to 6n, and 9n plus 9n plus 2 equals to 20, and this whole equals to 0. So now in the next step we have two cases. So the first case is we write n minus 3 equals to 0, and the other case is we write n squared plus 6n plus 20 equals to 0. So in this case you will get the value of n which is equals to 3. So now in order to find the other values of n we need to solve this quadratic equation. So now first I can check is this quadratic equation have real roots or not. So here I can use the discriminant formula. So now first I can write the coefficients here, and you have the coefficient of a is 1, b is 6 and c is 20. And our quadratic formula will be looks like in this form. We have n equals to minus b. Sorry, I can use the discriminant formula. So the discriminant formula will be in this form: delta equals to b squared minus 4 times of ac. Here I can use this discriminant formula to check the roots of the given quadratic equation. So now I can check put the values of ABC here, and you get 6 squared minus 4 times of A is 1 and C is 20. So it will becomes 36 minus 80 and it is equals to minus 44. So you see here our delta is less than 0, then we can say that the roots of the above quadratic equation has complex roots, or we can say that it has no real root, so that we will just reject it this case, and we have only the root of the given question is n equals to 3. So this is the our final answer of this problem, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.